Hello, everyone, and thank you very much for joining us for another live webinar session brought to you by Tech Media and allaboutcircuits.com. My name is Jason Montgomery, and I'll be the moderator for this session here today. Today's session's title is Omron's Innovation in DC Power Switching, and as you can tell, it's brought to us by Omron. Let me tell you a little bit about our presenter and a few other housekeeping items before we hand it off for the presentation. Today's presenter is Zac Hendrix from Omron, who is product manager for relays. He attended Northern Illinois University and has a Bachelor of Science in Mechanical Engineering with an emphasis in sustainable energy. He has expertise with relay applications within the automated testing equipment, factory automation, and smart home building industries. And everyone, I do want to thank you again for joining us for this live session. And as a reminder, just like all of our other sessions, there will be a live Q&A that follows the presentation. So please make sure to submit any questions that you have, and Zac and I will look forward to getting into that once we've heard what he has to say. And with that, Zac, welcome, and I'll hand it off to you.
Hi, everyone. Thank you, Jason, and thank you for joining today's webinar. Again, my name is Zac Hendrix. I'm the Relay Product Manager here at Omron Electronic Components in the Americas region. And today I'd like to present to you guys Omron's Relay Innovations for DC Power Switching. So while the bulk of today's webinar will be revolving around our new and existing products for DC power, I also want to introduce you guys to Omron's relay portfolio as a whole, and talk about some of our focus products, some of our newer releases, talk about the product categories, and also go into the engineering side of things at Omron. So what type of engineering support we can offer you, especially for your relay needs, what we've done in the past, who you can talk to, and what we can do to more align our products with your application, with your designs. I also want to talk about how we decide on what relay products we're going to develop, our kind of background process on developing that, and what our targets are for that development. So what target industries, what target applications, and what we will deem as a good product target for the future of our relay portfolio. So another thing I do want to mention before we dive in is that I will have 4 poll questions within this webinar. I would really appreciate it if you could just give a brief multiple choice answer, and we can use that to further improve our future webinars and actually use towards our research for new product development. It's great to get your feedback, so I appreciate your support on that. And the first question is going to pop up now. It's what brings you to today's webinar? And I'll just give you a few seconds to toss your answer in. There should be 4 choices for you to choose from. Okay, thank you for that, guys. So where I'm starting is the relay overview. And this is a contact current versus contact arrangement graph of some of our most high demand products and some of our most focused products. What we don't have included on this map are some of our non-PCB type DC power relays, which will be in this presentation. They're more automotive grade, so they have higher vibrational specs. They're a little bit bulkier, but they can handle very high voltage loads, and very interesting for battery applications and energy storage and EV charging. We also have lines of general purpose and industrial relays, and those are some more robust DIN rail mounted relays, some that can handle higher motor loads, some that are safety relays, things of that nature. And then we come back to the bulk of our product, and where most of our demand is our PCB power relays and power relays in general, and also our signal relays over here on the left-hand side. Now, before I go into those, there is another mention here at the right, the G9T A and TB, and these are relatively new releases. They're AC latching relays for very high amperage. So we're talking about 60 amps and 120 amps at 277 VAC for both products. So these come in multiple terminal types, and it's a latching relay, meaning when you empower the coil, it mechanically latches in place, and you don't have to further empower the coil until you're pulsing that latch to break, to unlatch and open the circuit. So these are great options if you're talking about power consumption savings. You'll have lower power usage. You don't have to continuously power that coil. Now, moving back to the left, are our signal relays. So these are our electromechanical signal relays, which are primarily 2-form-C relays. And why they're called signal relays is because they're passing very low loads between 0 and 3 amps. So this is things like alarm signals, test signal switching, very low load signals to contactors, powering coils at very low amperage and voltage. But these are very tiny. They have multiple channels, so 2-form-C. They switch different modes, they're transfer contacts, and you'll see them typically in like thermostats to switch HVAC controls. You'll see them in automated test equipment, such as test signal switching for semiconductor products. And you'll see them in things like medical equipment, very small devices, switching signals in, say, ultrasound devices. Now, kind of similar to that, and more of a comprehensive product line is our G3VM series, and that's our MOSFET relays. So these are solid state relays, meaning they have no physical components within the product. They operate, you power an LED like you would power a coil, but much less power consumption. And that interacts with a photodiode array, a PDA, which interacts with a MOSFET chip to perform the switching. So because there's no physical contacts, you can save space, a smaller device, a smaller relay, and you also won't have a rise in contact resistance from that physical touch over time. So it's a consistent resistance. It's very small. It can support 0 to 10 amps. So it kind of falls into low signal loads up to power loads. And again, it has a much longer lifetime because you're not having anything mechanically switch within it. So this product line has over 200 part numbers within the G3VM family, and they have a variety of different package sizes and different power ratings. So like I said, from 0 to 10 amps DC and 0.5 amps AC in a very, very small package, down to the size of a grain of rice. And the reason why it's notated here, the family name and the new, means that we come up with a lot of MOSFETs throughout the year. There's a lot of different characteristic types to pass different frequencies of signals and different power levels, and also to provide different performance when transmitting a signal from the input to the output. So you can expect these throughout the course of a year. Now, the center area, when we're talking about, I'm sorry, this circle is a little wonky, but the center area, the PCB power relays, is where our platform relays exist. It's where most of the relays from today's presentation are, and it's where you'll see the most variety, both in form factor, so contact arrangement, and also contact current and voltage. Now we have ranging from 3 amps all the way to 200 amps now with our full portfolio, and we have latching types within, so types where you empower it, it mechanically latches, and you can keep that power running without any power consumption to that coil, and then pulse it to release. You have the standard 1-form-A relay on the bottom here, which is where relays typically start off. They're just on-off relays, and most of the new products will start off as 1-form-A. We'll talk about that more on the next slide. And then what I want you to notice about this page is that the further you move right, the more new products you'll see. So the products that I have here are the products I will be talking about for DC power. So G2RGX, G5PZX, G7EB, G9KA, or G9KB and G9KA. So as you can see, they're tending towards the right. That's because at Omron, we're trying to expand our high capacity, but maintain a very small package size. So we're trying to save space for the customer, for you guys, while also reaching the trend of higher capacity, especially for industries like the energy industry, for inverters and such, in energy storage. So now to further expand on that, we have this slide here, which kind of shows you 3 of our target industries, well, really 4 target industries, and shows you what high current, mid current, and low current new products have been developed to fit the needs of those types of industries. And firstly, we have energy for high current. And like I said, we're talking PV inverters, we're talking rapid shutdown, we're talking uninterruptible power supplies, EV chargers. These all require very high amperage and voltage, and they typically use contactors for this type of switching. Now, Omron wants to offer solutions that are more board-based. We want to offer relays, which are smaller. Even if you need multiple relays to replace a contactor, you're still going to have a lower profile and probably an easier assembly than a large overbearing contactor. And sometimes you might not even need the full ratings of that contactor and could use less relays instead of that previous solution. Next is the most interesting in my opinion. So we're talking about factory and building automation here, and we're talking mid-current. So our example is G5Q. Now G5Q is one of our platform relays, so it has a lot of focus and a lot of engineering development built into it. So it's been around for quite some time. It started off as a 3-amp relay, and now it's a 10-amp relay standard. And you can just see here how many different types we have. We have a high current type, high inrush type, explosion proof type, and all of these different types are in the same package size, have the same footprint, but are just internally built differently in order to offer that higher capacity or that new characteristic. And this is what I want to hone in on, is that these additions were based off of customer input. We talked with our customers and we developed new products that better fit applications based on their needs. So if you bring us a product that we currently have released and you need a different contact form, or you need a high inrush version, or a different case, or a different safety standard, we will do a feasibility study and we will pursue the best ratings to fit the customer needs, the application needs, the design needs. So this is always a consideration. Please talk to your Omron representative or reach out to me if that's the case. And lastly, we have ATE, and this is our low current, particularly pertaining to the MOSFET. And like I said, MOSFETs, the G3VM family has over 200 part numbers with different varying characteristics, different package sizes, different options overall. And we're consistently releasing new products. So as we release these, you can expect to see that smaller and smaller packages will be able to handle more and more power. So when you're not test signal switching and need specific characteristics for semiconductor test, you can look to it as a power relay and just look at it as a downsizing option for a load that you were passing in a larger relay previously. And that's our goal with these new releases. Another goal of ours is to create modules with these MOSFETs. So build in multiple discrete MOSFETs into one module, like the G3VM here, G3VM-M, I'm sorry. And what this is, most of our MOSFETs are 1form A relays. We do have 1form B options, but this takes discrete MOSFETs and creates a 1form C in one package. We also have another module that creates a very low leakage current option, comparable to read and electromechanical relays in one package by using additional circuitry with these discrete relays. So a lot of different new technologies that we create to meet the needs of our target industries. So before I jump into the DC power relays on the docket today and sort of go over the overview of this slide, I'm going to ask the second poll question that I really hope you guys can give us feedback on. So what are the challenges that you currently face with whatever switching solution you're using today? And we have a few options here. Just go ahead and give us a quick selection and then we'll get back to it. Okay, thank you very much. So where I want to start on this page, firstly, I want to say that everything that's on this page, I will detail at some point within this presentation. I want to give you guys a full look at what we have to offer from a DC switching perspective when it comes to relays. Now, firstly, if we look down here, the G2RG is an existing relay that is not considered a new product by any means. So this was a 110 VDC relay at 5 amps, so very low level load. Now, with the increasing need for high DC power, for low DC power, we've decided to invest engineering resources into developing a bigger portfolio to reach the needs of those applications. battery applications, energy storage applications, electric vehicle charging, and mobility applications. So in doing so, we've expanded the G2RG series into a new G2RGX that you see here. We're looking at the products within inrush current bypass for residential energy storage system. We'll talk about all three products here. So this is between the 400 and 500 VDC range for lower amperage loads. Above that, we have the G7LX, which has multiple DC ratings and can support up to 1,000 volts DC in a small PCB package and break that current while eliminating arc, which I'll discuss in more detail as we go through. Next, I'm not going to circle all these, but we have many G9E series. You could see G9EA, G9ED, C, and H. And you can see that they fall in different categories. So we have different ratings depending on what type of application we're looking at. So even if the ratings that you see here today don't apply to you, that doesn't mean that our relays can't withstand whatever you're looking for. It means that we need further testing data or further ratings added. So the relays that are within this second box here are for safety shutdown of residential energy storage system. So that means they're the main relay within these energy storage system and passing the full DC load. So G7LX again, the G9 series, and then the newest G9KB, which is a bidirectional relay we'll detail later. And then over here on the lower right, we have safety shutdown of low voltage residential ESS. So these are for low voltage applications in battery storage, so low DC, 60 volts. And these are building upon existing products that were released as high AC products, but now we also have DC ratings released. The G7EB currently has a 60 VDC rating, and the G9KA will later on this year. Okay. So now we're going to get into our first product, which is the G2RGX. And this, I'll admit, it looks a little bit different than most relays that you would see, mainly because of that T-shaped head. But as you can see from like the scale of my hand and the device itself, it's a relatively small, slim relay. And within this package, we could support up to 500 VDC at 10 amps. So very a medium to low current, but very high voltage for that small package. And that's really what we're honing in on, is the high DC voltage, eliminating the arc in that high small package and keeping the compact footprint. Now, this is the product I mentioned earlier, the G2RG, which is the existing 110 VDC 5 amp relay that we expanded upon. And what we did is we just added that T-shaped head in order to better suppress the arc that is generated at high VDC. So we're still maintaining the same power consumption as the existing product. It's still a 2-form A relay, and I'll explain why we need it as a 2-form A relay. And also, we've bolstered the temperature spec of this relay. So not only can it go up to 70 degrees Celsius, but it can go 15 degrees further to 85 degrees Celsius. So let's take a look at the size and circuit connection. So you can see the T-shaped head, it does add some extra width to the product, but that's important. We'll see it on the next slide. The circuit connection example explains why we have, or shows you what it means to be a 2-form A, and I'll explain why we have that. So a 2-pole series wiring means 2-form A, so it's still on and off, or well, I should say on and off type switching, but we have 4 contacts being opened and closed instead of just 2 contacts. So 3 and 4 are going to open close when we're turning on and off, and then same thing with 6 and 5 here. And essentially what we're doing there is we're increasing the contact gap, making it harder for an arc to be maintained when passing a high DC load. So usually for safety standards, you need at least 3 millimeters of contact gap for certain applications, and that's to maintain safety so that the arc will be more easily broken. But in this case, we're kind of multiplying by 2 that single contact opening to have 2 contact gaps. So it's just one plus the other, and now we have an even larger contact gap. So now on the next page, this is where we're looking at the T-shaped structure. And this is just specifically for the G2RGX, since 500 VDC is very high for that small package. we've added permanent magnets and other technology in order to quickly and efficiently diminish the arc that would form from a high DC load while breaking that type of load in an application. So the way that we did this, the way that we developed this technology here on the left, is with the simulation software that I'm detailing here on the right. So on the right, this first section here is showing kind of the simulation software showing how an arc develops. So between the contacts, when they open, we still have that DC current still pushing its way from one contact to the other with the gap present. Now, when you have permanent magnets and other technology stretching that arc, as we see as we move up the line here, we have less and less arcing, and then that arc gets fully diminished. And in order to best develop the magnetism, the magnetic force that's needed to do this as quickly as possible, we look at the temperature, the pressure, and the hot gas flow through the simulation technology and quickly come up with a design that we feel comfortable about that will be a good factor of safety for a released product. And that's exactly what it does. It improves the quality of our design and improves the lead time of development. So we started using this for our DC relay technology, and all of the new DC relays will include this simulation technology. So we're confident with the product we're releasing to a higher level, to a higher degree, and then they will come to market quicker than they previously would just guest test and revise almost. There is a quick video that I do want to show that just shows you that arc being born and then that arc being stretched, and then it'll just be diminished. So let's take a look at that. So as you can see, it gets born, it starts being stretched, and once it gets to a certain point, it no longer has the power to maintain itself, and it will just diminish, and there will be no circuit flowing. The circuit will be entirely open. Let's go back to our presentation. Okay, so example applications for the G2RGX. So we're not limited to these applications. These are the target applications that this relay was developed for. And this will also apply to the G5PZX to some extent, because it's also a lower amperage, mid to low range amperage relay for these type of applications. So as you can see, we have an inverter system here, and inverter systems need to store their energy. Let me turn on drawing again. So we're in the storage section at the bottom here. And within that storage section, we need an inrush protection relay, which doesn't need to carry the full brunt of the load, the high current, high VDC. It only needs to carry that voltage level at a lower current because it's offering inrush protection on an offshoot from the main circuit. So what you need for products like these are very small, compact products like the G2RGX, like the G5PZX, that could withstand and break that arc suppression, so we don't have to worry about the relay arcing to a point of failure or to case deformation from flammability, stuff like that. So that's why this G2RGX is really a good fit for these type of applications. And also the lower coil power consumption coil. Like I said, we're saving in energy by using these coils and by just maintaining the same power consumption from the previous iteration to the next generation, meaning we don't have to spend so much on powering these relays. Next is the G5PZX, and this is also an expansion of an existing AC relay, which is the G5PZ series. So it's still very small. It's a little bit wider just as at the base as G2RGX, but we don't have that T-shaped head. And the reason why we don't need that T-shaped head in this scenario is because really we rate this relay at a 200 VDC 20 amp. It is, like I said, it's built upon the G5PZ series, or the G5PZE, which is the high capacity 20 amp version. And that series had a 530 milliwatt power consumption, which is very low for that type of current and voltage. And then we're also transmitting that to the new generation. So the X also has a very low power consumption. Now, where we will make up for the lower voltage from this model versus the G2RGX is that we recommend connecting two pieces of this G5PZX in series in order to provide that 400 VDC capability with the G5PZX. So maintaining 20 amp carrying and then also being able to switch 400 VDC. If you don't need 400 VDC, if your application is less than 200 volts or at 200 volts, you can use this product off the shelf and it will work perfectly for your needs. This is just to meet the needs of those specific industries that I'm describing. Now, also in this expansion, we've also added 15 degrees of additional temperature capacity. So we're moving from 70 degrees Celsius up to 85 degrees Celsius. So this is what I'm talking about for circuit connection recommendation. This is not a polarized relay, so it's a bidirectional switching relay, meaning that it is great for charge and discharge applications at that lower current, that 20 amp current. This is just a wiring diagram of one piece. We can provide more detailed specs and engineering help if you have an application for this. You just need to discuss with me and I'll facilitate with our engineers overseas. But this is where our secondary spec, the bidirectional switching to or double G5PZX series circuit connection. And this offers still just an on-off connection, but doubling the voltage from 200 volts to 400 volts for applications in need of that higher DC power. So G5PZ example applications. These are the same trends that we saw for the G2RGX. So downsizing of the equipment, increasing the battery storage capacity. So we want the higher DC voltage, we want higher current capabilities, we want the small size, we want to maintain as small a size as possible. And that's what we offer with these two new products. The applications that we target are, of course, the energy storage, vehicle to home, so charging electric vehicles from the home, factory automation, inverter and servo motor driving, power supply switching for DC power supplies, and also uninterruptible power supplies. So what the main need in these applications is not necessarily switching and breaking that high main current, the main circuit, but for the inrush protection, which we have an example of, a crude example of an inverter circuit that has that inrush relay built in. So there are times where we'll need 200 VDC, 20 amp relay, or a 10 amp relay just for switching a power supply that's DC, or for switching inverters. So that's where we'll apply directly for the main circuit. But a lot of the times we'll see what we have detailed here on the lower left. My apologies for these circles. Okay, so we're on slide 14. We're going to talk about the G70B, which is moving from the low amperage up to the high amperage. But this product was initially released as an AC relay, but we've added DC ratings at a later time. So as you can see, bigger than what we've seen before, but there's a reason for the increase in size, just simplistic footprint. The reason that it's a larger size is because this relay can support 40 amps at 800 VAC, 100 amps at 480 VAC, and 50 amps at 60 VDC. So it is great for the applications here on the lower left. We have PV inverters, industrial uninterruptible power supplies, industrial inverters, and then for the DC rating, energy storage and EV charging. This is great for low voltage applications within those designs. So some key facts about this relay is one, it comes in two coil voltages, 12 and 24. It's got a very low, I'm going to remove that circle for a second, very low power consumption because it has a holding voltage feature. And we'll talk about how you can reduce that power consumption by using this relay and the next relay soon. So another very important part of these new larger power relays is the contact resistance rating and the contact resistance engineering that went into these products. And the reason why this is so important is because when you're passing high AC and high DC loads, you're going to have incredible amounts of temperature being developed from that current running through the relay, running through those contacts. And the lower your contact resistance is, the better your thermal properties will be, the lower the temperature output of the relay itself. So in this case, on our data sheet, we rated at 5 milliohms, but on the next page, I'll show you where our actual test data for this product is. Below that, you see the contact gap of 3.6 millimeters, larger than what is needed for safety standards, higher 85 degrees Celsius temperature margin. And then safety standards, we do have UL and TUV ratings for this product. And you can take a look at the detailed UL ratings and TUV ratings that we have on the data sheet. If they don't apply to you, that's fine. If you need new ratings added, please talk to us and we can look to have those ratings added for your specific design. We're always open to that. Like I said, these were developed with certain target applications in mind. So we start off with certain ratings, and then like the G5Q that I showed earlier, we build, add more and more ratings and just have it more applicable and just a bigger design margin overall. So this is where I'm showing you the contact resistance data from testing multiple samples of the G70B. So we rated it at 5 milliohms, and we could see the actual initial contact resistance is down by 0.5 and 0.7 milliohms, significantly lower than our actual datasheet rating. So a lot of room there. And I'll show you when we're talking about the next product, how that influences the temperature when passing the load through the relay. The other thing I wanted to show here is we have two models available. We have our standard product for new designs. It's an Omron compatible footprint, or an Omron original footprint, I should say. But we also know that there are existing relays of similar capacity that have a certain footprint that we wanted to make sure that we have a compatible type to offer as well, in case you find the ratings of the G70B a little bit more beneficial than what you've seen from competition or what you've used previously. So this is the holding voltage feature, which is a really big add to these types of relays, these very high power relays. So in order to keep that contact pressure, you need a good deal of power to the coil in order to close those contacts and keep them closed. But we have incorporated a holding voltage feature for these new relays that wants you to drive between 100 and 120% of the rated voltage, so the 12 or 24 volt coils, for 0.1 to 3 seconds. Then after that, you can drop that rated voltage down to 45 to 65% of the rating. So with that, you will save you can drop down from 2,800 milliwatts maximum all the way down to 575 milliwatts of power consumption to the coil to keep that relay empowered. So a lot of power savings with that feature. Next, I'm not going to go into too much detail on the applications for the G9KB, because the G9KA here is going to have very similar applications, just at a higher contact current margin. And you can see it's a bit bigger than the G70B that we just went through, and there's a reason for that as well. But it's a 50 cubed relay, so 50 millimeters cubed. So why this is so large is because it's relatively small compared to what is being used for a switching solution for this type of load. So you can see the original rating was a 200 amp, 800 VAC relay. So switching and carrying at that level is pretty massive for a small PCB type relay. And coming soon, just within the next few months, we're going to add a DC rating to this, which is why I've included it in this presentation. So it's a low voltage version, 60 volts DC at 200 amps. And we'll have a future spec that will be added to the data sheet in time come. So it should be coming out in July. Just look for it on our website and you'll be able to see the entirety of the spec. So what I want to talk about is the entire spec of this and what it is used for, what applications the AC product is used for, and where we can see a transition to the DC load rating for different applications. So firstly, we want to look at the coil voltage, so how much power consumption with this relay. And because of the coil voltage, the holding voltage feature, once again, we can reduce from 100% down to 45%, saving a lot of power savings once again. Now next, you remember back to the G70B that was rated at 5 milliohms for the datasheet rating. Now this is rated at 0.2 milliohms at 200 amps for 30 minutes, so tested over a period of 30 minutes. That is a very, very low contact resistance. A lot of engineering effort went into making this contact resistance so low, and you'll see how much this applies to the actual output of the relay in use. So low heat generation, we're looking at 0.18 milliohms from the Omron G9KA compared to a similar relay of 0.4 milliohms contact resistance. So by having just that amount of difference in milliohms of contact resistance, we see a drop of 16.3 Celsius between our relay and competition. So we're 16.3 degrees cooler, and that is including using a cooling fan and heat sinks for the competitive relay. So on the fixed terminal, we see a massive reduction in temperature, which means on the next page, we could see that saves more room for, or it saves in assembly costs. We need to assemble less heat sinks, assemble less cooling fans, reduction of the bill of materials, and an overall ease in PCB design. So this is why it's been so important for us to keep improving our contact resistance output for our new relays, especially for these high power considerations. So this is what I've been talking about in terms of creating PCB relays for the contactor realm, the very high voltage realm. So you can see on the left, contactors are very bulky. They do carry and switch a very high voltage and very high amperage, but sometimes you don't need that high of amperage or that high of voltage switched. Mainly focus on the amperage side of things. So it's potential that we can use 6 relays in the place of a single contactor. Now, it may be the same amount of space in terms of surface area, or it may be smaller if we need to carry less of a load through these relays. But we're saving on, it's going to be an easier assembly. We're definitely going to save on profile height, as we see here. Even if this relay is large for a relay, we're still lower profile by far than any contactor. And just putting these on a board, on a dense board, we may save on surface area as well. And this is what we mean. We're carrying the same loads as the contactor. We're lower profile. We're still applicable in that arena. And then maybe an easier wiring and assembly in the end. The two main application examples I want to show for the G70B and G9KA are first the power conditioning system. So we have a built-out inverter system here that shows you where we would use the AC relays, circled there or boxed there in red, the G70B and G9KA. So the main functions would be to carry the current when connected to the power system and also as an emergency shutoff for the AC side. And this is typically where you'd see a contactor. Now, on the other end of things, since we have a DC, we have other DC relays that we've talked about, and also DC ratings for these high power relays, we can see them in use in the batteries or the storage system within these PCS. So the battery will need a DC relay to carry either low voltage or high voltage DC loads, and we'll also need DC relays between the booster and the DC portion of the inverter. So still application with the DC spec of these two products. UPS, similar needs as the PCS, which are low heat generation, small size, and very high AC and DC voltage capability. So in this application image, we're showing 3 relays on the inverter and the converter side of this uninterruptible power supply, which is really just for emergency switching scenarios. Now, you can also see that there's energy storage built into this. We have an inverter. We need to store that energy. We'll also need those DC power relays at low and high voltage. So we're thinking G5PZX, G2RGX, G9KA, and KB as our low voltage DC relays or our low amperage DC relays, depending on what you need. Next, we're going to talk about the G9KB, which is a relay that came out last month, and it is a very high DC power relay. So this is to carry the main brunt of the DC loads for these type of storage applications. Now this relay is smaller than the G9KA, but it's carrying and switching 50 amps at 600 VDC, so very high power. It still maintains above a 3 millimeter contact gap. It has that very low contact resistance that we've been talking about. It has ratings that are more applicable to energy storage systems, but that doesn't mean that's the limitation of the G9KB. It's a very robust relay. It also has holding voltage feature for lowering power consumption usage, moving from 2.8 watts down to 0.57 watts, depending on how much you're driving at that holding voltage. And then we're also talking about an 85 degrees C temperature margin. Now, you can see at the bottom here, we have ratings that pertain to energy storage applications. Again, if you want to add new ratings, you'll have to discuss with us, and we're very open to improving the spec based on your needs. One thing that I want to note is that for these relays, we're talking about a PCB relay, a smaller option that could support very large loads that a contactor typically would. So we need to properly utilize these relays and follow all the safety guidelines provided in the data sheet or precaution documents in order to make sure that these perform at the level that they're supposed to, and that we don't have any issues with safety or malfunction. So we do offer a guideline to how to mount these relays in order to get the performance that we rate on our data sheet. So the main feature of this relay in particular is that it is a bidirectional, very high DC current relay. So typically when you have a charge or discharge path for a battery for electric vehicle charging, you need two relays, two polarized relays, one for charge and one for discharge, because the current can only flow one way for a polarized relay. So since this is a bidirectional relay, we've negated the need for a secondary relay. It could both charge and discharge the load at 50 amps, 600 VDC. So it definitely saves on bill of material if we only need one relay rather than two. And example applications. And so this is, we're talking about PV inverters and energy storage systems which kind of go hand in hand, but the needs of the energy industry have been shifting to requiring more and more relays at a higher and higher capacity because there's more and more residential use. So we're seeing a lot of solar systems that are built residentially. So we have the solar panel PV inverter system on a home, and we need someplace to store that power. It has becoming more valuable to store the power at home than it is to sell back to the grid. So you're conserving this power, you're saving this energy for future use, and you need relays to break the DC voltage, or to break the DC voltage at higher current levels in case of an emergency, or in case you need to break the discharge or charge circuit. And that's where the G9KA and the other high DC relays come into play. Before I move on to the next slide, I do want to mention the carbon neutrality policy that we have on this page. So this is something that Omron is working towards. We aim our new product development and our target industries at further developing society to what will benefit progression the most. So how could we promote the betterment of society? And in doing so, we've targeted things like solar power. We want to reduce our carbon footprint. And we create relays such as the DC power relays and the high AC power relays to support these applications, to support electric vehicle charging, to move away from gas usage and high carbon emissions. And that's what it's meaning by through 2050. It's our goal to continue this process and develop products in that direction. So the second example is EV charging, like I just mentioned. Applications, they sometimes will be switching with no load, but for the G9KB, we can switch high-level loads at that high 600 VDC. So these relays would act as safety shutdown relays in the event of an emergency for a vehicle-to-home charging, so charging at your home, versus an electrical vehicle charger for power distribution units. So fast DC charging for multiple units. So on the left, we have an inrush prevention DC relay, that's the G2RGX, G5PZX we talked about earlier. And then we have the main safety shutdown relay, which would be the G9KB in this case, or a G7LX, depending on the contact or the current being passed through this main circuit. Now, on the opposite end, you'll need multiple safety shutdown relays for multiple distribution units for multiple multiple units being charged, either cars or smaller vehicle or smaller EV type vehicles. So speaking of the G7LX, it can almost be interchangeable with the G9KB in terms of high voltage capability. It's slightly smaller than the G70B. It's relatively the same size. If you could see, I have them stacked here and then side by side stacked. It's relatively the same size as the G70B, the AC relay we talked about before, but this can support up to 1000 VDC in this package at smaller amperage than the G9KB, which was the previous mention. So we have two types here. We have a standard type and a general purpose type. The general purpose is a little bit less expensive of a relay, and it has a little bit less contact ratings than you would see for the standard version. But still, both of these products can support 600 VDC for 30 amps and 20 amps respectively, and 1000 VDC for 25 amps and 20 amps respectively. So very high DC voltages in these packages. And we're really aiming for PV power systems, energy storage systems, and uninterruptible power supplies for that high VDC end of that system. Again, we have normal and reverse polarity loads. Depending on your needs, these are really developed for energy storage and for other energy applications that need low cycles. But we could always test and add specs or test at whatever ratings are acceptable for your type of design. And I don't have an application slide for that because it kind of goes hand in hand with what we looked at for G9KB. It's the similar type of applications, EV charging and energy storage systems. So the next group of products is going to summarize, it's going to finalize the relays I'm going to talk about today. And these are our G9E series, which contain screw terminal types with leads. It contains a newer PCB type relay, and it also contains a relay that we have not yet released that I just wanted to detail to you today so you can get a glimpse at what we're coming down with in terms of high DC energy relays. So this is taking a look at all of the G9E series, or most of the G9E series, I should say. And as you increase alphabetically, you're really increasing your capacity, your current carrying, and your current switching for those products. So moving from G9EA to H, we move 60, 100, 150, 200, and 300 amps at the rated carry current. Now, what I find interesting about our ratings for these is that we only rate them to 400 VDC across the board for these products at that rated current. But as you'll see, I'll bring up that DC map again. We also have ratings outside of that rated load. So we can increase that voltage depending on customer needs and provide a rating that falls outside of what we actually spec on our data sheet. So I don't want that to be a limitation for you guys thinking that this is the end all be all for the ratings of this product type. And also, as you can see, we move along to the right and we've increased the temperature capacity for some of the newer products within the series. So to further bolster the G9E series, we also have a compact DC power relay known as the G9EJ, which is a PCB type high DC relay. And what I forgot to mention on the last slide, but I can mention here, is that these have qualities of automotive relays. So they have higher vibrational specs than you'd see from the previous mentions, meaning they could be used for the main power on a small electric vehicles like a neighborhood electric vehicle, an RV, a ski-doo, a jet ski, an electric scooter, a forklift, things like that. We can be using these for either accessories or lighting and power on these electric vehicles, or main power in the case of the relays that we saw previously, charge and discharge relay for the batteries on board. And so they'll also have better vibration specs if I didn't mention that. And that's what this relay is for. It's for the smaller power applications on these type of devices. And it can also be used, again, back in energy storage system as the inverter bypass relay in those cases. And then lastly, we have the G9EK preliminary spec. So this is a relay that we're going to release the G9EK standard version. We're looking to release it in March of 2023. And the high capacity version, the -E, we're looking to release a little bit later in next year, around the December timeframe. So what is really important about this relay is that it's a bidirectional relay. It's a DC relay, so charge and discharge. It's great for quick battery chargers, main relay of battery junctions in those smaller mobility vehicles that I mentioned, and great for energy storage systems like the G9EKB was. Another thing that's great about these particular relays is that it is a gasless relay. So some very high DC relays are filled with a hermetically sealed, or they have a hermetically sealed chamber that have a gas to eliminate the arc within that relay. And those typically cost a lot more money than those without. Now, with our other arc technology that I've explained earlier in this presentation, we've eliminated the need for that gas relay, and we can just eliminate the arc without it. So we're essentially offering a lower cost relay that can handle the same loads as a gas-filled, hermetically sealed relay. I didn't even mention the rating of this relay, which is 200 amps at 500 VAC. And then for the high capacity, we're talking 250 amps at 500 VDC. So very, very high level load. But the other thing that I wanted to mention is the short circuit capacity. So this is a trend. It's improving more and more. It's increasing more and more. And we need to have products that can withstand that type of short circuit current. And in this case, for the standard, we have a 5,000 amp rating and an 8,000 amp rating for the high voltage type. So very, very high for both of those ratings. So I mentioned I was going to come back to this. This is the same slide that I started off with, but I just wanted to make mention again of the ratings outside of what was on the data sheet. So G90A, we can 10,000 operations at 800 VDC at 30 amps. Again, for the G90C, 100 amps, 1,000 volts for 1,000 operations. So these ratings aren't limited to that lower 400 VDC, although that is still high for a lot of applications. So please keep that in mind when you're considering a relay for a lesser or a higher load than what we rate. I would recommend that you talk to us first before experimenting so we can give you advice and do testing on our own to provide you with the best output from our products. Now, to sort of sum up the applications for all of these products, I have two slides for residential and industrial applications. And these target applications are by no means limiting what these relays can do in terms of applicability, but this is what they were targeted for. So PV inverters, we've made a lot of we've talked a lot about this today. So relay for high voltage interruption, specifically for power conditioning and junction box, fuel cells for high voltage interruption, EV charger for high voltage interruption and safety shutdown, storage system, that's the same as energy storage system, ESS, and then HEV and EV. So for a stationary charger, these relays are great, especially for DC charging applications. They can switch the full load, they can switch the bypass loads, but we can also offer these for electric vehicles that are not automobile grade. So we're talking about the forklifts, we're talking about the smaller tractors and the golf carts and jet skis and things like that. That's where we'll see a lot of application for charge and discharge and for accessories within the car or the vehicle. Next is industrial applications. So again, PV inverter, just at a larger level. Fuel cell, same thing, larger level. Capacitor, really meaning the same thing as energy storage. And then exactly what I was just saying. So a forklift, a tractor, that's more of the things that you'll see in industrial, a pallet mover, things of that nature. They'll have a battery on board. It needs to be charged. It needs some way to disconnect the main DC circuits within it. That's where we'll see the G9KB. We'll more so see the G9EJ, the G9E series, and relays of that nature. So before I talk about this slide, I want to come to our last poll question, which is what product discussed today was most relevant to your projects? So I have a list of all of the products that I went over, and I've kind of given either the exact rated load or the rated load range depending on the products in that category. If you could just select which one most pertains to your needs, that would be greatly appreciated. Okay, thank you. So this last page, or well, this last showcase that I'm giving you here is a look at our webpage, omroncomponents.com. So on here, from the main webpage, you'll see a tab called Solutions and Industries. And within this pull down, you'll have both Solutions and Industries. Solutions will give you more product-oriented solutions and talk to you about what kind of products we have. But the Industries is a very interesting location, as it contains these three solutions pages that are very application-oriented, very industry-oriented, but also very product-oriented. So solution for automated test equipment, we'll see all of Omron Components products for that industry for semiconductor test. And we'll also talk about applications and which products to select for different functions. The one that pertains to this webinar most accurately is the energy market solutions. So within that, it will show you a lot of the applications I talked about today, give details on those applications, and direct you to different relays and also other switching and sensing products that would fit into that application. Now, on the other end, if you're not interested in finding per application, it also gives you all of the features and benefits of the AC and DC relays that I talked about today in great detail, and it'll link you to different solutions for those products. And lastly, we also have solutions for the casino industry. So really a great resource to learn more about our products and about our targets as Omron Components. Now, this is you can find us page. It shows where our head office is located. We're in Hoffman Estates. It gives you a QR code to our website, and we have a lot of information on our website. We show what's new. We can find all our data sheets, a lot of information about products and how to utilize them and what different selections there are. Also, we are active on social media. So we have the QRs for LinkedIn, Twitter, and YouTube here. Please stop by, especially by our YouTube page. I have videos that I posted on there about my products, as well as a lot of other members of my marketing team who have talked about either their industries or their products that they want to facilitate to you guys as a customer. So please feel free to stop by. And that is it for my presentation today. I really hope you guys got something out of it, and thank you very much for joining. If you do want to reach out to me, my email is zachary.hendrix@omron.com, and I'd be happy to help you with questions, talk detail, or connect you with your local Omron sales rep. But please feel free to reach out. I really appreciate it. And I'm going to pass it back to Jason here to jump into our Q&A. Thanks again.
Thank you so much, Zach. Can you hear me okay? This is Jason.
Yes, I can. Thanks, Jason.
Great. Well, thanks for a great presentation, Zach. We've got some questions in here. And as a reminder for everyone, we are going to go through with a Q&A right now. So if there are any more questions that you have, make sure to use that Q&A box that you see on the screen. And Zach and I will be happy to go through what we have some time to discuss right now. So Zach, the first question that I'm seeing is, are there other DC relays from Omron that weren't covered today?
There actually are, yes. So I didn't detail them here today because they're really an entirely different DC voltage range. But we have PCB automotive relays for both 12 and 24 VDC loads. And we have newer PCB relays, and we also have existing plug-in relays, which is more of the traditional automotive relay technology. But our aim with these types of products is to find 12 and 24 volt battery applications for these products. So I kind of mentioned them earlier, like accessories in golf carts or RVs or electric wheelchairs. You might need a lamp load, like a lamp on the end device, or a window motor load switched for smaller mobility vehicles. But I do have material on these that I can share. So if you'd like to reach out about them, I'd be more than happy to share about those products too.
Great. Thank you, Zach. Another question that I'm seeing here is, will Omron help transition from other switching types to these relays?
Yeah, of course. So our engineers want to help make the move to our board-based solution with as much ease as possible. So if you don't have much experience with these kinds of relays or transitioning to these relays, we can offer our opinions on PCB design from what we've seen in the past or what we have on record. But most designs will kind of differ to a certain extent. So we'll talk with our team case by case and work through it with you guys.
And one question we see a lot, Zach, that I see here on the Q&A is about pricing. Who should they reach out to? Who's the best contact to talk about pricing here?
Okay. So pricing will be worked out through our sales members. It will depend primarily on your yearly usage of the product, but I can connect you guys to your local salesperson based on your location. If you're not already familiar, just please send me an email. Again, it's Zachary, ZACHARY .HENDRIX @omron.com.
And another question here, maybe about other contacts within the company as well, Zach, is there a separate product manager for other Omron relays?
For other Omron relays, I'm assuming like products that I haven't talked about today. There isn't, no. So I handle all of the relays from our components group. So the products we talked about today aren't the limit. If you have interest in some relays from the beginning of my presentation, like the MOSFET G3VMs or the other PCB relays or industrial or general purpose relays, I'm the contact for that, more or less. So I'm more than happy to give you more details on them.
And what about availability? Are these relays stocked at distributors?
Yeah. All of these DC relays today are available through major distributors. Please feel free to give a quick online search. You can find them pretty easy, and you can pick up any of these products for like testing or prototyping.
Another question about your part of the world there at Omron, Zach, which is, does your branch of Omron only sell relay products?
No. We offer switching and sensing products too. I'm the contact for relays, like I said, but we also have a product manager in my group that handles switches, connectors, and sensors. So you can find all these items on our webpage, but you can also reach out to our product manager directly if you want to talk in detail about a specific product or your project. His name is Roland Hiso, and his email will have the same format as mine. So roland.hiso, HISO, @omron.com.
Great. And I can say from personal experience, I know that everyone out there at Omron is always very responsive and timely with getting back to people with questions big and small. So I definitely encourage everyone in attendance to take advantage of these resources if you do have any other additional questions. I see one more question here, Zach, and everyone in the audience, if you've got anything else on your mind, definitely feel free to submit it now while we have Zach on the line. Next question that I'm seeing is, do you have a plan for a relay with higher amperage?
So higher amperage, the products that I detailed today, 200 amp was our limit. We are looking to expand to higher and higher load capabilities. So right now we're looking at developing maybe a 300 amp relay, PCB type for AC voltage applications. We're researching the market for this product, and more info will come out later if we do choose to pursue. It's not a DC relay, but please let me know if you want to take a look at our preliminary spec, and we could talk through that to see if there's interest or to help us decide to pursue this.
Got it. Thank you very much. Let's see here, Zach. I think I did just get a question in here. I don't know if you can see that question on the back end. They're asking for a specific email address, maybe for someone there in Omron.
Sure. So yeah, I can answer that back to the asker. But the The question is, who is the switch commodity person? And that's the person I just mentioned, Roland Hiso. So roland.hiso@omron.com. If you need that written out, I can provide that to you guys. Jason, is there a way for you to
Yes,
shoot that to the feed?
I can do that. So it's roland.hiso@omron.
Correct.
Great. I'll send that. Just sent that answer off to the respondent there, and I think we should be good, Zach.
Perfect. Thank you.
Wonderful. Well, Zach, I'm not seeing any more questions that have come in right now. It's been a great Q&A and a great presentation. Is there anything on your mind here that you want to close us up with, or anything you want to emphasize as we're rounding out the session here?
Not anything in particular. Again, I wanted to really promote at the beginning of this webinar that we're more than happy to talk to you guys about improving, changing our products, and also creating new relays. So if you have anything on your mind or something that you see is missing that you would love to see from Omron, please let us know. And thank you very much for joining this webinar. And thank you, Jason, for facilitating the Q&A.
Great. Well, I want to echo that as well. Thank you very much to Zach and Omron for joining us for this session. Thank you to everyone who was in our live audience and made for a great Q&A session afterwards as well. Definitely, when you are done here, go check out Omron's other webinars that you'll find on All About Circuits, and I believe you'll be redirected to their page at the conclusion of this webinar as well. Reach out to Zach with more questions that you have. I've been Jason Montgomery with EE Tech Media and allaboutcircuits.com. Thanks for joining us for this live webinar session, and we look forward to seeing you at another live Omron session again sometime soon.